What's going on? Welcome to physics class. Let's get into this. I'm going to go quickly, and I want you guys to, be vibrant. Ask me questions. All of that kind of stuff. This is going to be an interesting class. I'm going to be excited about it. Hopefully you'll be excited about it. Let's get this party started. All right. First thing I'm going to do is, and I'm just making this lecture up off the top of my head. First thing I'm going to do a lot of erasing, so I want you guys to copy things down a lot, or you know what, better yet, learn to take pictures on your computer screen. My towel is all wet. I don't even know. One second. Hold on. I'll be right back. I'm just going to go and get my sweater so that I can grab.
I don't care about the cat. Yeah, that's bad. Those guys can pay $135 an hour.
Alright, here we go. Coming over here. Got it. I'm down. Alright, good. This is my sweater. I don't know why I'm erasing this. I'm supposed to keep it up there. Alright, check this out. Here's what we got. Make sure you ask questions, because I'm going to cut out the do you understand part, or all of this kind of stuff. Are we cool? All that kind of stuff. I want you to ask questions when you think of them. Is that a promise? I'm just going to ask that right now. That's the last question I'm going to ask and wait for. Is that a promise? You're going to ask questions when you see them, when you think of them, because I'm going to burn right through this lecture. Yes? No? Come on, help me out here. This is why I don't ask questions as much, because it takes long. Alright, sounds good. Awesome, good. What I've done before, and this is what I've done in the last class, so if you don't remember, watch the archives, is I've kicked the ball, and it's gone this far, and we know that it goes in a parabola kind of motion, and we were able to calculate out the range equation. Now, I'm just going to write this down. I want you to write this down on a piece of paper. The range for this, and I'm going to write it up here at the corner, just so you can keep it here. Range is equal to, what was it? Oh yeah, it was V naught squared times sine of 2 theta all over G. Got it? I'm erasing that. Now I told you, don't memorize that equation, because that equation only really works when I am talking about something that gets kicked off over here and lands at the exact same height that it's at. And so it doesn't always work perfectly. Alright, another equation that I did, and actually to be honest with you, I can't remember what that equation is, but let's just try to figure it out, is what if I kicked a ball horizontally off of a cliff that goes at height h? Well, I'll solve the problem out for you real quick, because I don't remember what the equation is, and I'm not asking you to memorize these equations. But if I kick it off horizontally, I want to figure out the time it takes, and so I would use delta y equals v naught t plus 1/2 at squared. That delta y is actually h. By the way, my coordinates for this is positive going down and positive going forward. So it's actually positive h, and is equal to v naught, but there's no velocity in the y direction. My acceleration is gravity, and I want to figure out how long it takes, so I multiply it by 2, divide by g, square root both sides, and I have t equals the square root of 2h over g. If you don't believe me, solve it yourself. Alright. Then I want to figure out how far it goes in that amount of time, so I use the same equation, delta x equals v naught t plus 1/2 at squared, but in the x direction there is no acceleration, and so therefore if I wanted to figure out my range, which is delta x, I simply multiply the velocity that it was going at, v naught, times the square root of 2h over g. Are we cool with that? Say yes, I'm cool with that. Yes, good, awesome. Oops, I'm sorry, I asked if you're cool with that. I shouldn't have. Let me write that equation down over here. Range is equal to v naught times the square root of 2h over g. Alright, I'm going to do another problem for you. I just did that one really quickly. Just going to do one of these. Alright, okay, here we go. The next problem I'm going to do is, this is going to be a doozy, and so I'm going to go through it, and I'm going to try to hit all of these points, but I wanted to actually show you something really cool. I just want to put these on the side. of the table for now. Let's think about this. What if we kicked a ball off of a cliff? We kind of combine these two ideas. We kick the ball off of a cliff, and it goes from H1 and it finishes at H2. Okay? Draw this picture because I'm going to have to erase it. I won't have enough room. I'm just letting you know now. So, let's see. I'm going to draw a picture smaller. Cliff, kicked it, starts at H1, finishes at H2, some height over here, lands on top of some other cliff. And I want to figure out how far it went. R equals what? I know the acceleration. It's gravity. I know that I kick it off at an angle v naught, at an angle theta. I'm sorry, at a velocity v naught, at an angle theta. And I want to figure out how far it goes. H1, H2. Cool? If you want to figure out exactly when that reaches the ground, then you can just make H2 equal to 0, and that would kill that. Alright. I'm going to kind of take the same approach here. So you guys, I should go through this quickly because you should be used to it. I did the same exact thing here and here. What I'm going to look at is first thing I'm going to do is I'm going to take the vector v naught and I'm going to break it up into its components. So I have v naught going this way. I can break that up into its x part and its y part. The x part, v naught x, ends up being v naught times cosine theta. If you don't believe me, go back to SOHCAHTOA and work that out. You'll find that it's true. V naught y is equal to v naught sine theta. Fair. What I've done is I've broken this v naught that's going at an angle into two parts, going in the x direction and going in the y direction. Now I'm going to look at just the y direction. My variables, v naught y, v final y, time, acceleration in the y direction, and delta y. Those are the 5 things that I usually look for. I know what my v initial y is, I know what my acceleration is, I know what my delta y is, and I don't know what time is, but that is what I'm looking for. My v final is my don't know, don't care, which indicates for me the equation I would use is delta y equals v naught t plus 1/2 a t squared. And of course this is v naught in the y direction and acceleration in the y direction. Let me know. Remember, I'm going to go fast, so let me know if you guys get confused at this point. The delta y is actually your height final minus your height initial. I'm going to call a standard coordinate system. So positive y over here, positive x. Positive y goes up, positive x goes this one. So the final height is actually h2 minus h1. Bear in mind that this is actually going to be a negative number because h2 is going to be smaller than h1. That's just the way I have it set up. I could have it, we could have it set up a little bit differently, but, what the heck. Alright, so h2 is smaller than h1. I know that because that's the final height minus the initial height. I know my v naught y is actually v naught cosine of theta. I know my acceleration of y is actually negative g, because up is positive, gravity is going down. So it's minus 1/2 g times t squared. By the way, I forgot a t over here. It's v naught cosine theta t, because the v naught y is v naught cosine theta, the t's still there. Cool? I'm going to take everything and pull him over. So I got 1/2 g t squared minus v naught cosine theta times t plus h2 minus h1 equals 0. All I did was I took this thing over here and this thing over here. That made this negative a positive, this positive a negative. I can look at this and I say, hey, that looks a lot to me like the quadratic equation, like a x squared plus bx plus c equals 0. The only thing is, instead of x's, I have t's, and I have a bunch of letters over here. So I can apply the quadratic equation to this, and I'll say, okay, the time is equal to negative b. B is negative v naught cosine theta, so it's going to be v naught cosine theta plus or minus the square root of this squared. So it's v naught squared cosine squared theta minus 4 times a, so that's 1/2 g, times c, which is this, h2 minus h1. I'm sorry, I'm out of room over here. I'm going to ask this question. I want you to write this down, by the way. Are you guys confused with any of these parts? Can you not see any of those parts? That's a fair question to ask. Because I want you to write this down. I'll read it off to you. It says v naught cosine theta plus or minus a big square root sign. This says v naught squared. This says cosine squared theta. There's the square. Minus 4 times 1/2 times g times the parentheses h2 minus h1.
What is G?
All divided by, 1 second, I'll get to that in just a second, all divided by 2 times 1/2 g. What is g? G is gravity. G is 9.8 meters per second squared. That's all it represents.
Oh,
It's the acceleration, it comes from the acceleration in the y direction is negative g. That's all that is. Got it? I know. This looks horrible. This looks atrocious. Bear with me, alright? Just calm down. Well, I mean, I'm not even thinking that you guys are like freaking out, but I mean, hang in there. This right here kills itself because you got 2 and the 1/2. This right here, 4 and 1/2 make it 2. Got it? All right. Let me think. Hold on. I'm thinking. Yeah. Why is it all over g and not 2 times 1/2 g? Oh, yeah. See, Julia, you figured it out. 2 times 1/2 g is the same as g. All right. Now what I'm going to do is, this is the time. I can plug it into this machine, and it will come up with a number. Hopefully, I think. Got it? So I'll plug it into the machine, and it'll come up with some number, and whatever these variables are, you can tell me whatever that you want, and I'll give it to you. Now I'm going to say, in that amount of time, whatever it is, I'll calculate it out later. I'm going to look in the x direction, and see how far it traveled in that amount of time. This is the same exact thing I was doing with the range equation, same exact thing I just did at the beginning of class with you. So, in the x direction, we have delta x equals v naught t plus 1/2 at squared. And in this case, there is no velocity in the x direction. This v naught is actually v naught x because I'm talking about in the x direction. Delta x is my range, that's what I'm looking for. So range is equal to v naught x, which is v naught cosine theta, times this junk. Cool? Times that. Alright, take a picture of the screen. Control the 6 button or whatever, the button above the 6 button. I'm going to erase this. I'm going to erase at least the top half over here. Okay? Can I do that? You guys ready? Alright, well, hopefully you are. I'm going to erase just this top half. Only because I want the space to write out this monster completely. r is equal to v naught cosine theta times v naught cosine theta. You know what? I'm going to distribute this v naught cosine theta in. So this would be v naught squared cosine squared theta plus or minus v naught cosine theta times the square root. You not see that square root? The square root of v naught squared cosine squared theta. Is this going to work? Is this going to work? Just trying to figure it out now. Hold on 1 second. No, wait. I messed something up. I'll tell you what I messed up. It's not that bad. It's not that bad. I apologize. I truly apologize. I erased where I messed up, but I know how to fix it. You guys ready? I'm looking at this, and there's too many cosine of thetas inside of the equation. The reason being is because there shouldn't be cosines of thetas here. Because this calculation was from the y direction. And remember, the y direction had a v naught sine theta. So all I got to do is just replace this with a sine theta. Since I screwed that up, I apologize, by the way. Do you understand why I did that? You understand? I'm going to stop, pause, and say, do you understand why I had to replace with a sine theta? And you got to go back in your notes and fix that. I'm sorry. Julia, Catherine, I'm going to wait for you to answer. Do you understand why there's a sine theta over here, not a cosine theta? I don't have a whole lot of time, so I need you to
I don't
answer.
really get it.
What is that?
I don't know, I don't really get it.
You don't really get what?
I don't get why you changed it.
Oh. Because this calculation, it was all the stuff I erased up here, came from the y direction. So when I was talking about the y direction, the v naught y that I was supposed to use, I accidentally used v naught cosine theta, and I shouldn't have used that because v naught y is actually v naught sine theta. That's why I changed it.
Okay,
Does that make sense now? I changed it because I screwed up.
sure.
And I realized I screwed up because I was like, v naught x is going to be v naught cosine theta. Wait a second, why do I have v naught cosine theta up here? Oh, that should be a v naught sine theta. That's what my brain was thinking. So I kind of messed it up. All right, here it is. So we're working with trig functions because cosine works with the x-axis and y corresponds to the, the y corresponds to the v naught sine theta. Something's going on that's funky. This is clicking sound. I don't know what it is. It sounds like a bug, which kind of creeps me out. Alright, anyway. I don't want to erase that. I'm going to erase this part right here. Alright, now, what I'm going to do is I'm going to just write this thing down. I'm going to distribute this v naught cosine into this thing. So r is equal to, okay, can you review why you're putting this t equation into the parentheses? Oh, well, Julia, because I calculate out the time that the thing was in the air for. And so when I'm looking at the x direction, I say, okay, there is no time in the y direction, there is no time in the x direction. They're the same thing. So all I'm doing is I'm just replacing the time because, you know, time in the x direction is the same as time in the y direction. So I calculated out the time and say I get 10 seconds or whatever. It's going to give me a number in the amount of seconds. I calculated out the time, and then that will actually give me the velocity, or it will give me how many seconds in the air for, and then I just look at the x direction to see, well, how far did it go if it was going at this velocity for 10 seconds? Or something like that. Does that make sense to you now? So anyway, I'm going to write this equation down again without the parentheses. I'm just going to write this monster out, and I'm just going to distribute this cosine in there. So I have v naught squared sine theta cosine theta plus or minus v naught cosine theta times the square root. Oops. Can't see that square root. You guys can barely see that square root. Square root of v naught squared sine squared theta minus 2g h2 minus h1 parentheses. The square root goes all the way up to the end over there. All divided by g. Are we cool with that? Now you guys understand why I spent 3 weeks. I'm going to erase this because it's just the same thing up here. Now you guys understand why I spent the first 3 weeks covering math with you, because physics isn't for the faint of heart. If I showed this to my Algebra 1 students, they would just cry. So, this is what we got. We cool? Now, here's the things I want to show you that is actually really interesting. This corresponds to the scenario where you have something that is being kicked off of a cliff and landing on some other cliff. The first cliff is H1, the second cliff is H2, and then it goes that far, so you're figuring out the range, and you kick it with a velocity v naught at an angle of theta. We cool? What would happen, my friends? Okay, and just to review, this is the range equation. This corresponds to if you have something that's on solid ground all the way across the board and you just kick it like that. This is, I guess it's called the horizontal shot equation. I've just made that up right now. But all this corresponds to is if you're on a cliff that's of H1 and you shoot it off horizontally, it will go, this is how far it will go. Don't memorize any of these equations. Just memorize, the only equation you really should memorize is the one delta x equals v naught t plus 1 half a t squared. It's the one we learned a long time ago. These all come from that idea. Here's the thing I want to show you that's actually really interesting, really cool. What happens if H1 equals H2, what would happen? Let me show you something I think is interesting. If H1 is equal to H2, then H2 minus H1, this part over here would be 0. That would effectively, and I'm applying it to this idea right here, that would effectively kill this whole part of this equation from the minus 2g times 0. Let me write this down. Your range would now become v naught squared sine theta cosine theta plus or minus v naught cosine theta times the square root of v naught squared sine squared theta all divided by g. And if it's alright with you, I'm going to do some chalkboard math, which basically means I'm not going to write another line down. Oh, I'll do it, whatever. V naught squared sine theta cosine theta plus or minus. This thing would translate to v naught cosine or v naught sine theta. So this whole thing right here is just v naught squared sine theta cosine theta divided by g. Then I can add these. Well, actually, I got to take into this case of 2 scenarios. If I add them, this would be 2 times this, because they're, I'm adding something plus itself. If I'm subtracting them, then this whole thing ends up being 0. So that's good too. So I know that the answer is either 0 or it's twice this, which is 2 v naught squared sine theta cosine theta all divided by g. This is in the case of subtracting them. This is in the case of adding them. Then what I can do is I recognize that 2 sine theta cosine theta is actually the sine of 2 theta. So this would be v naught squared sine of 2 theta all divided by g. That was my range. That is what this equation reduces to if H1 is equal to H2. Where else do you see this equation? I wish you had your microphones on so you guys can be like, what is going on? That is so crazy cool. But right now you guys are like, I don't care. It's right there. That equation is the same exact one as that one. Which makes sense because if you think about this scenario, I'm dropping this h1 down to the same height as what this thing is. And I effectively reduce this crazy equation into the range equation. I'm going to erase it one more time. Take a picture if you want. You get 3 seconds. 3, 2, 1, done. I'm erasing this part. Don't worry, I'm archiving this. You guys can watch it as much as you want. Because it's that cool. What happens if theta equals 0? Okay, if theta is equal to 0, what is the sine of 0 degrees? 0. And the cosine of 0, I keep writing theta, is also 0. No, that's wrong. It's 1. Sorry, it's 1. Yeah. It's been a while since I took trig. You guys remember trig, right? Sine of theta is 0, or sine of 0 is equal to 0, cosine of 0 is equal to 1. So let's plug that into here. Let's see what information we can get. Let's see. Oh, and let's let h2 equal to 0. Let's do that. I'll have theta is equal to 0 and h2 is equal to 0 in this particular case. All right, let me see what I do. All right, so range is equal to v naught squared times 0 times 1. Well, that just kills that whole first part right there. That's dead. So I get plus or minus v naught times the cosine of theta, which is 1, times the square root of 0 minus 2 times g times h2 minus h1. But h2 was 0, so it's just negative h1, which makes this positive h1. All divided by g. Let me simplify that just a little bit. And I'm going to go plus or minus v naught, the square root of 2gh divided by the square root of g squared. I want to put that g inside of this fraction, so I got to make a square root over it. The square root of g squared is the same as g, so that's all I'm doing. I'm going to put it over a common fraction, so this is going to be equal to v naught, the square root of 2h divided by g. Because there's one g upstairs, but there's 2 downstairs, those kill each other. That's my range. Go on, I'm going to wait for it. I'm waiting. I gotta finish. Type something, type your response. I'm waiting for your response. Ta-da! Exactly. In this scenario, the height that it landed at was 0. And the angle that you kicked it off at was theta. Well, all we did here was we just kind of customized this scenario to make it look exactly like that one, and the math worked it out perfectly. That, my friends, is the power of physics. I just think that's so cool. It's so exciting for me, personally. I want to show you other things. I want to show you a lot more things. But for now, I want you to just kind of absorb this. So, have fun with this. And good luck doing your physics stuff.